I have to start with something I saw just the other night driving home.
Oh, yeah.
I turned this corner, and just hanging there, right above the horizon, was this massive orange harvest moon.
Mm.
It looked huge. I mean, like I could literally reach out the car window and just grab it.
It's a
Yeah.
classic.
But that's the thing, right? I know for a fact the moon doesn't actually change size. So today we're looking at why my brain is, well, lying to me.
It's the ultimate brain teaser. We're diving into what's known as the moon illusion.
You okay?
And what's just fascinating, looking at the sources we've pulled, is how long humans have been obsessing over this.
Yeah.
We've got notes here from Aristotle in 330 BC,
Wow.
all the way to Da Vinci.
Yeah.
All of them trying to crack the exact same code.
And most people, I feel like if you ask them, they have an answer ready. They'll say, oh, it's the atmosphere acting like a magnifying lens.
That's the most intuitive answer for sure.
Yeah.
But according to the data, it's completely wrong. The atmosphere does distort the color. That's why it looks orange. But it doesn't magnify the size. In fact, physically, the moon is about 1.5% smaller on the horizon.
Wait. Smaller? That feels completely backwards.
I know, but it's just simple geometry. When the moon is overhead, you're looking straight out at it. When it's on the horizon, well, you're looking across the Earth's radius, which adds about 4,000 miles of distance between you and the moon.
Okay, so the object is technically smaller and farther away, but my brain is seeing it as a giant dinner plate. We need to prove. We need to prove this. How do we test it?
Well, there's a classic experiment in the literature. It's called the pebble test.
The pebble test.
Okay, you can actually do this at home tonight. Just take a small pebble, say about 1/3 of an inch wide, and hold it out at arm's length, about 25 inches away.
All right, I'm picturing it.
When the moon is high up, at its zenith, that little pebble will perfectly cover it.
Okay.
Then later, when you see that massive-looking moon on the horizon, do the exact same thing. The pebble will still cover it perfectly.
So you're saying the image hitting my retina hasn't changed by a single pixel.
Exactly. The optical data is identical.
That is unsettling. That means the error isn't in my eye, it's in the software, in the processing.
Precisely. And this is where the scientists really start to argue. There isn't one single consensus, but the leading theory is what's called the Ponzo illusion.
This is the one about how we see the shape of the sky, right?
Right. Our brains don't interpret the sky as a perfect sphere. We see it as a flattened dome. We instinctively feel that the horizon, which is behind trees and buildings, is much, much farther away than the sky directly above us.
I see. So if my brain thinks the horizon is incredibly far away, but the moon on my retina is the same size.
Your brain runs a quick calculation. It says, if that object is that far away and still takes up this much space in my vision, it must be physically enormous. It scales it up.
It's a mental autocorrect.
That's a great way to put it. Arthur Schopenhauer argued this back in 1813. He called the illusion cerebral, not optical.
Yeah.
But there's another layer, too. The Ebbinghaus illusion, or relative size.
That's all about context, right? When the moon is high up, it's just this lonely dot in a massive empty void.
Exactly. There's nothing to compare it to. But on the horizon, it's right next to a house or a tree. And compared to a house, the moon looks huge. So your brain emphasizes that contrast.
So context is, it's everything. It completely changes how you process the raw data. And, speaking of context and figuring out where things fit into the bigger picture.
I see where you're going with this.
This deep dive is sponsored by Embersilk. If you're trying to figure out where AI fits into your business context, whether that's for training, automation, or software development, you need to know where agents will make the most impact. Check out embersilk.com to clarify your tech strategy.
Connecting that back to visual context, you can actually break the moon illusion instantly.
How do you do that?
Just look at the horizon moon through a cardboard tube.
Like a paper towel roll.
Anything that blocks out the terrain. The moment you hide the trees and the horizon line, the moon instantly shrinks right back to its normal size.
Because you've removed all the data points my brain was using to run that autocorrect.
Exactly.
We usually talk about illusions like they're glitches, like a bug in the system, but this feels different. It's not that my brain is broken, it's that it's working incredibly hard to construct a 3D reality from a 2D image.
I completely agree. It's a feature, not a bug. We don't just objectively record the world like a camera, we build it. We construct it based on logic and experience and all these little cues.
Which leaves us with a final kind of lingering question. If my brain automatically resizes the moon just because it's near a tree, what other facts about my daily reality are actually just mental autocorrects.
Now, that is a question worth losing some sleep over.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.